Hello everyone, you are welcome to this channel. In this video, we are going to focus on limits of a function, and under that, we are going to consider the standard formula of limit. Okay, now let's get started. So our first formula of limit that we can think of is limit of constant function. So it can be written as limit of k as x approaches a. Alright, so the k here is a constant. Okay, so let's take an example and see how it works. So limit of 2, this is an example, as x approaches 4, automatically the answer is 2. Alright, so that's it. So when the question is given as limit of a constant, it can be any number that you can think of. It can be any number that you can think of. Any number at all. 0, -1, +1, even decimals. Okay. So whenever it is limit of a constant, the answer is always a constant. Let's consider the second formula. The second formula is basically talking about limit of a function. Okay. Alright, limit of a function is very simple. So this can also be written as limit of f of x, okay, and the f of x is a function as x approaches a. Okay, so here let's take an example and see how it works. Okay, therefore you'll get to understand what it really means. Alright, so an example, let's take limit of 2x plus 3 as x approaches 4. So in this case, it's very simple. Unlike the first one, this one, since here is a function and it has a variable which is x inside, what you are going to do is that the number that the x approaches, we are going to put it into the function that is being given in the question. So very simple. So it's going to be 2. So in place of the x, we are going to plug in the 4. That's going to be 4 plus 3. Okay. So 4 by 2 is equal to 8. Then plus 3. And the answer here is going to be 11 as our final answer. Alright. So these are the first two standard formulas. Let's consider the third one. Let's consider the third one. The third one also talks about the same limit of a function. Just that this one, it's going to be a quadratic function. Okay. Not only quadratic function, we can have a function with the highest power of x to be, let's say 3, it can be 4, it can be 5. But at this point, let's consider the one with power 2. So let's say we have limit of x power k. Okay, so this is what I'm trying to say, that here it can be x power 2, it can be power 3, it can be power 4. Any power, any number of power that you'll be given, you are still going to solve it. Alright, so okay, as x approaches a. So at this point, it's the same thing as the second one. We are going to use the same procedure, okay? Alright, so using the same procedure, let's take one example and solve it. So limit of, let's say, x power 3, okay, as x approaches 2. Alright, so in this case, what we are going to do is, you can see that this one is a function, just like the second one, okay? This one is a function. So for that matter, we are going to plug in the 2. That's the number the x approaches, okay? So it's going to be 2 exponent 3. So 2 power 3 and 2 power 3 is equal to 8. That's the answer for the question 3. Alright, now let's consider our fourth standard formula. I can see our space is being occupied, so let's clean up so that we can get enough space for the fourth one. Okay, so our fourth formula, we are still on the limit of a function. Okay, we are still on the limit of a function, but this time the functions that are going to be given are going to be two functions. Okay, so f of x and g of x. But at this point, the two functions that are being given, they are going to multiply each other. I don't know if you get me. So it's going to be two functions though, but these two functions are going to be multiplied by each other. Okay, all right. So let's take an example and see how we go about it. So assume you have limit of, let's say, 2x plus 4, okay, multiplying x plus 1. So we can clearly see that the first one is f of x, okay, and the second one is g of x. So these are the two functions and they are multiplying each other. Okay, all right. So how are we going to solve it? Just like the third standard formula and the second one, here too is the same thing. We are going to plug in the number the x approaches into the given function in the question. Okay, so here we're going to rewrite our function, but wherever we see x, we're going to put in 2 plus 4, okay, then 2 plus 1. All right, let's continue to simplify. So 2 by 2 is equal to 4 plus 4, that's 8. All right, so 8 bracket open, 2 plus 1 is 3. So 8 times 3 is equal to 24, as we know already. Okay, so this is our fourth standard formula for limits. Now let's consider our fifth one. The fifth one too is almost the same as the fourth one, but the only difference is that although it consists of two functions, but at this point the two functions, they are not going to multiply, but they are going to divide each other. So if we have limit of f of x, that's the first function, divided by g of x, the second function, as x approaches a. This is the fifth standard formula of limits. Okay, now let's take an example and solve it. So let's assume we have limit of, so at this point let's use the same example that we used for the fourth formula. Okay, so here we are going to use the same thing, just that they are the two functions, they are no more going to multiply, but rather they are going to divide each other. So f of x is what? 2x plus 4. So 2x plus 4, all right, divided by the g of x, which is x plus 1. X plus 1. As x approaches, that is 2. Okay, so here the same way we are going to plug in 2 into the functions. So it's going to be 2 bracket open 2 plus 4, all divided by this x. So we place 2. It's going to be 2 plus 1. All right. Okay. So here 2 by 2 is 4 plus 4, all divided by 3. So we are gonna get 8 at the numerator, then 3 at the denominator. So this is going to be our final answer. We can go further and deduce it into decimal form, but I prefer we leave it in the fraction form so that you can get an accurate answer. Okay, so 8 over 3. All right. There is our last and very last standard limit that we are going to consider. That's very simple, but then this particular standard formula is involved with infinity. Okay, it involves infinity. So let's get into it. All right, so the sixth one, it involves infinity. So we know a formula for infinity. Formula for infinity Formula for infinity is, that's a formula, sorry, the symbol for infinity here is this, okay. Alright, so this is what you are going to use. So basically you can be given a question like, or the question is written in this form: uh, limit of, let's say, any number, let's say x, let's take x, as x approaches, so it always approaches the infinity, okay. All right, so let's take an example, then we solve it. So if we have limits of let's say 2, let's say 25 divided by x squared as x approaches infinity. So this particular question, how are we going to solve it? We can see that based on what we knew already, there is a function, all right, and since it's a function, what we do, we are going to plug in the number that the x approaches. So that means we are going to plug in the infinity here, okay. But there's something that we need to know, we shouldn't forget. So we need to note this: if we have 1 over infinity, it's always equal to 0. It doesn't really matter if the exponent or the power of the infinity is more than 1. No matter the power of the infinity, we are still going to get 0. It can be 1, it can be 2, even 100, 20, 5, 6, any power that you can think of, it's always equal to 0. So 1 over infinity is equal to 0, okay. So in this case, what you are going to do is that you are going to plug in the infinity into the function. So the function is 25 divided by x squared, but the x here is going to be replaced by the infinity, so it's going to be infinity squared. And we already know that 1 over infinity is equal to 0. This means that any number divided by infinity, no matter the power of the infinity, is equal to 0. So the answer for this question is equal to 0. Hope it's clear. Alright, let's consider one more example. So let's take this example for instance. Let's assume we have limit of 5x squared minus 1 divided by 2x squared plus 1, okay, as x approaches infinity. So in this case, how are we going to solve it? You see, you can really think that you can plug in the infinity straight ahead and we get our answer. But if you do that, we are not going to get our answer. What we are going to get is really going to be horrible, okay? Because we know that 1 over infinity is equal to 0, okay? So if we put infinity here and put infinity here, infinity over infinity is what? Cancelled out. And therefore, what we are going to get is, it will be something else, okay? Alright, so now what are we going to do? So what we are going to do is that when such a question is given, what we need to do is we need to find the highest power of x in the function. So here the highest power of x in the function is what? Is x squared. Now we know that the highest power of x in the function, that's x squared. After that, what we need to do next is that we take each term, then we divide by the highest power of x. Okay, so let's continue. So if we take the first term of the numerator, which is 5x squared, so if we take 5x squared, then we divide that one by the highest power of x, which is x squared minus 1. That's the next term. We divide that one by the highest power of x, which is x squared, all divided by, then we come to the denominator, so 2x squared divided by the highest power of x, which is what? X squared. So x squared plus 1 over x squared. Now we can see that this x squared cancelled this x squared, and also this one also cancels this. So it's going to be left with 5 minus 1 over x squared, okay, all divided by 2 plus 1 over x squared, okay. All right, so here there's no way we can further simplify it. So at this point, what we need to do is that we are going to plug in the infinity into what we've gotten right now, okay. So wherever we see x in these functions, we are going to put infinity over there. So it's going to be 5 minus 1 over infinity squared, okay, all divided by 2 plus 1 over infinity squared. All right, and we already know that 1 over infinity is equal to 0. So automatically this place is 0, this is 0. So it's going to be 5 minus 0 all divided by 2 plus 0. So our answer is going to be 5 over 2. So this is going to be our last answer. Okay, our final answer. Alright. So this is infinity for us. Now let's solve one more example so that we draw the curtains down for today. Alright, so our next example is limit of 7x divided by x minus 4 as x approaches infinity. So just like the example that we just solved, I know you can follow the same procedure. You can pause the video, then follow the same procedure and solve this one. It's not difficult. So here too, we are going to identify our highest power of x in the function, and our highest power of x in the function is x, okay, that's x, and it's of power what? Power 1, okay, so that's x. So at this point, what we are going to do is that we are going to take each term in the numerator. So the first term in the numerator is 7x. So we are going to divide that one by the highest power of x, which is x, all divided by, we take the denominator, the first term is with x, we divide that one by x, minus 4, that one to be divided by x. Okay, so we can clearly see that the x here cancels this one, then this also cancels this, so it's going to be left with 7 divided by 1 minus 4 over x, okay. So here there's no way we are going to further simplify it. So at this point we are going to plug in the infinity, okay. So it's going to be 7 over 1 minus 4 over infinity, okay. And we know that 1 over infinity is 0. So basically, automatically, 4 over infinity is also equal to 0. So 7 over 1 minus 4 over 4 infinity. Sorry, so this is going to be 0, okay. So this is automatically going to be 0. Therefore, our answer for this is 7. Okay, so this is where we are drawing the curtains down. Thank you for joining this video, and I hope you subscribe for more videos that are yet to come. Thank you.